Welcome to Amos T Online Class. Amos T Kumagbe here. You can subscribe to my YouTube channel, Amos T Online Class. Follow me on TikTok, Amos T Online Class, and of course on Facebook, Amos T Online Class and Amos T Kumagbe. Now, in today's video, we're solving a past question from NICO 2000 and 2000 question 12. Okay. Now, the problem says a gas occupies a certain volume at 27 degrees C. At what temperature will each volume be doubled, assuming that the pressure remains constant? Okay. Now, from this kind of question, they said we should assume that the pressure remains constant. That means we're using Charles law, because Charles law said that the volume of a fixed mass of gas is directly proportional to the absolute temperature, provided that the pressure is kept constant. Okay. Now, mathematically, Charles law can be stated as V being directly proportional to K. V being directly proportional to T. Okay, while V being directly proportional to T. Now, if we introduce a proportionality constant K, then our V will be equal to KT. Our V will be equal to KT. And then if we decide to make K the subject of the formula K, which is a proportionality constant, we're going to divide both sides by T. And of course, our K will be equal to VT, V divided by T. Okay, so our K, which is a proportionality constant, is equal to what? V over T, that is V divided by T. Now, this law can be restated mathematically as V1 divided by T1 is equal to what? V2 divided by T2. And this is the mathematical statement of Charles law. Okay, we're done with that. Now, let's quickly step into the solution now. The problem says a gas occupies a certain volume at 27 degrees C, a certain volume, okay? So that means the volume is unknown. So let's call it X. V1 is equal to X. Now, T1 from the question, they said it's 27 degrees C. 27 degrees C, but this temperature is not given in Kelvin, okay? So we have to convert 27 degrees C to Kelvin. And how do we do that? We're going to add 273 to 27 degrees C, and we're going to have our answer will be equal to 27 plus 273 will give us 300 Kelvin. 300 Kelvin, okay? So we're done with that. Now, the question says, at what pressure will each volume be doubled, assuming that its pressure remains constant, okay? So we're looking for T2. T2 is unknown, okay? Now, also V1, there is no numerical value for V1. Of course, there is no numerical value for what? V2, okay? Because V2 is equal to 2V1. Okay, because the question says at what temperature will each volume be doubled, okay? So if V1 is equal to X, then V2 will be equal to 2X. Okay, so this is what we have. Already we have the value for. We have V1 to be X, V2 to be 2X. Of course, T1 is equal to 300 Kelvin and T2 is unknown, okay? So how do we solve this kind of problem? We are going to cross multiply this equation. So we're going to cross multiply this equation, and then we're going to make T2 the subject of the formula. How do we do that? If we multiply V1 times T2, we're going to have V1 T2. And of course, this multiplied by this, we're going to have T1 V2. Okay, so that means our T2 will be equal to T2 will be equal to T1 V2 divided by V1, okay? Now, let's put in the values now. Our T1 from the solving is 300 Kelvin. Our V2 is equal to 2x. And of course, our V2 is equal to what? Our V1, because we're dividing T1, V2 divided by V1, okay? So our V1 is equal to X. So T2 mathematically is equal to 300 times 2x divided by x, okay? So this x will go here. We're left with 300 divided by 2. Sorry, 300 multiplied by 2. And if we check it out, 300 multiplied by 2 is equal to 600. Okay, so our T2 is equal to 600 Kelvin. And that is the final answer. This is the temperature at which the volume will be doubled, okay? If you're interested in this kind of videos, don't forget to like and share. Also subscribe to my YouTube channel, MST Online Class. Follow me on TikTok, MST Online Class, and of course on Facebook, MST Online Class and MST Kumagbe. See you in my subsequent videos. Bye.